All right, let's dive right into this explainer. Today, we're tackling a massive headache for anyone building and managing AI. We're looking at Headroom's really powerful integration with Strands Agents. Look, if you've been working with autonomous agents, you already know the deal. Managing their memory and context, it's incredibly difficult. So today, we're going to unpack exactly how Headroom solves this using some seriously clever compression techniques.
So here's the million-dollar question. How do you actually shrink an AI agent's context without it losing its mind? We hit this wall all the time as developers, right? You build this amazing agent, it starts grinding through complex tasks, and then bam, you're hit with bloated context windows, skyrocketing latency, and API costs that honestly just make you want to weep. You need the agent to remember everything, for sure, but you literally cannot afford to send the entire encyclopedia of your conversation history to the LLM every single time. So how do we shrink that payload without the agent forgetting the critical details?
Here's our roadmap for today. First, the context compression challenge. Second, 2 patterns for Strands Agents. Third, pattern 1, model wrapping. Fourth, pattern 2, the hook provider. Fifth, the maximum savings combo. And finally, supported providers. Section 1, the context compression challenge. Okay, so the crucial point to understand right off the bat is this. Bloated contexts burn compute and drive up latency. When your Strands agents are out there executing multi-step reasoning, pulling in external data, making tool calls, well, their context window fills up incredibly fast. And every extra token is literally extra time waiting for a response, plus extra money out of your pocket. You really need a strategic solution here. And that's exactly where Headroom steps in to act as an intelligent filter for your agents. Section 2, 2 patterns for Strands agents. The cool thing is, Headroom doesn't just hand you a one-size-fits-all hammer. Instead, it integrates through 2 distinct methods. On the left side, we've got model wrapping. This is for full conversation compression. Think of it as your broad stroke. Then over on the right, we have the hook provider for highly targeted tool output compression. That's your precision tool. So depending on where your token bloat is actually coming from, you get to choose your weapon. Section 3, pattern 1, model wrapping. Now, think of model wrapping kind of like vacuum sealing an entire suitcase of data before you check it in for a flight. When you use the model wrapper, you're engaging the full might of the Headroom pipeline. And this isn't just simple text truncation either. This core system is actually built on 3 sophisticated components: the cache aligner, the content router, and intelligent context. Working together, they analyze your entire conversation history and intelligently compress it. It perfectly preserves the semantic meaning, but drastically reduces the raw token count, and it wraps around the Strands model interface completely. Mechanically speaking, it is super seamless for you as a developer. Once it's wrapped, every single call to the stream function is automatically intercepted. The messages are compressed by that pipeline we just talked about, long before they ever reach the underlying LLM provider. Your agent just keeps chatting exactly as it normally would, completely unaware that its massive conversation history is being aggressively optimized right behind the scenes. Section 4, pattern 2, the hook provider. But what if your conversation history isn't actually the problem? What if the bloat is coming from massive API responses? Well, if model wrapping is our vacuum-sealed suitcase, this second pattern is more like a carefully sorted toiletry bag. Meet SmartCrusher. Instead of running the full heavy pipeline on the whole conversation, the hook provider targets tool outputs specifically. It uses Strands' built-in hook system to intercept the results of those tool calls. Say a tool returns a massive JSON array, like a database query throwing back thousands of rows. SmartCrusher jumps right in. It's this blazing fast JSON compression system that bypasses the heavy pipeline entirely, acting strictly as a precision tool for structured data. Now, you're probably wondering, wait, if it compresses the JSON array, doesn't the agent lose important data? Honestly, this is my favorite part. Think of SmartCrusher like a VIP bouncer at an exclusive club. It absolutely does not let just any data through. It only preserves the VIP data. The hook automatically flags and keeps error items, anomalous values, your statistical outliers, items that specifically match the query context, and boundary items like the first and last entries in an array. Everything else just gets compressed away. The agent gets the exact, pure signal it needs to make decisions without all that useless noise. Section 5, the maximum savings combo. So we've got the broad stroke and we've got the precision tool. What happens when we bring them both together? The math here is incredibly simple but incredibly powerful. Wrapping plus hooks equals maximum savings. Boom.
You don't have to choose just one. In fact, to get the absolute best compute reduction, Headroom actively encourages you to run both integrations simultaneously.
There's a quote straight from the documentation that perfectly summarizes this division of labor. It says, model wrapping compresses conversation history. Hooks compress individual tool results. They flawlessly complement each other. The wrapper keeps your ongoing agentic reasoning nice and lean, while the hook makes sure no rogue database query or massive API response suddenly blows up your context window mid-thought. It is just a beautifully comprehensive defense against token bloat.
Section 6. Supported providers under the hood.
Okay, so how does Strands actually translate all of this magic to your underlying LLMs? Headroom has made this incredibly clean and developer-friendly. It basically detects the underlying provider based purely on the Strands model you're using. So if you're using a Bedrock model, it immediately detects Anthropic via AWS Bedrock. Running locally with an Llama model, it treats it as OpenAI compatible. And hey, if you're building something totally proprietary with a custom model, it safely falls back to a token estimation method. You always know exactly how your specific model choice is being handled, ensuring the compression is always perfectly optimized for whatever your destination LLM is.
Which leaves us with one final, pretty exciting thought. We've seen the mechanics behind the model wrapper. We've seen the precision of the SmartCrusher hook. We know exactly how they combine to absolutely slash token counts. So, what will your agents achieve when context limits are simply no longer a barrier? When memory is vast, but API costs stay tiny? I highly encourage you to pull up the Headroom and Strands docs and start playing around with these compression tools today. Thank you so much for joining me on this explainer, and happy building.